good afternoon, ladies and gentlemen. I'm Mike Aizatsky. I'm working at the App Engine team, and today we're going to talk about batch data processing with Google App Engine. So during the session, live notes will be available on Google Wave, and you can also post your questions. So please write down this obscure URL, which is DS69F. So a little bit about agenda. So first of all, we're going to spend a little time talking about batch processing. What is it? How is it different from what Brad was talking about? Then, just to give a little introduction to the topic, I'll talk about how was data processing done in App Engine up to date. Then I'll tell you how we do batch processing at Google. Then we're going to spend the rest of the session about how we would like you to do your batch processing starting from today. So batch data processing is the task of offline processing lots and lots of data, lots of entities, thousands of entities. Common use cases are schema migration, exporting, inputting data, report generation, or whatever. And the core differences with what Brad was talking about, this is not real-time tasks. So this is something we should just run, take a cup of tea, or go to sleep, and it finishes in the morning, depending on how much data you've got. And for certain reason, this is a difficult stuff in App Engine. First of all, there are like certain restrictions in App Engine, which are not created because we like those, because we need those restrictions because we need automatic scalability, we need replication, reliability, and that's why we've got our 30-second request limit, which we're really trying to overcome. Sometimes there are transient errors in the systems, which happens in all distributed systems. We have non-zero latency for data store. We've got occasional, pretty rare, but still occasional timeouts. And what's really important, everyone got change in data sets. So you want to batch process over your change in data, which complicates this stuff a little bit. So when App Engine was launched, the only way to do batch data processing was to define a batch handler, do something which you'll be able to fit into 30 seconds, and start another process which will pin your page continuously. It might be just a curl, it might be a browser, and actually Alan is sitting here. Alan did that thing at the very first day when App Engine was launched. You remember there were invitations? So we had to process them somehow. So we created a browser page which was doing refresh and sending out all those invitations. There are some problems with this approach. First of all, we need some external driver which might fail, and like computer, which you have to keep your laptop on, you have to keep it plugged into network. If network fails, then your process stops. There are lots of difficulties with doing all the error handling, recoveries when errors happen, and the whole process is slow. I mean, what's the top QPS you can drive from a single computer? Maybe 50 if you're lucky enough, but I doubt that. And the whole state management of the process is really, really complex. People created lots of improvements over the 2 years when App Engine is over 2 years. You can communicate with the driver, you can use remote APIs for really complex scenarios. We even have got a bulk loader tool which does exactly that. This is something which is run on your computer and which drives the traffic to your web app to perform some batch computations. A year ago, we have launched a really, really nice system which we like a lot and we use throughout all apps, and this is called the task queue. Task queue can perform any kind of work outside of a user-driven request. You just enqueue it, it will be done later, and it's really reliable, high performance, high throughput system, but it's still got a 30-second limit. So people have created a task chaining technique. This is something which you use to overcome the 30-second limit. You basically run for some time, and as soon as you see that your time is ending, you're close to 25 seconds, you enqueue another task, finish your job. So you effectively split your job in batches, and each batch is processed by a separate task. And the code looks kind of OK. So you define the same kind of app handler. You get the next batch from somewhere. Common place to put starting point is in a request headers. Then you do some work, define where to continue work, and you enqueue the continuations. And it's really easy to start the whole process. You just enqueue the first task, and it will continue go through your data store. And people have been successfully using it, and there are lots of libraries for doing that kind of stuff. And task queue is really, really nice for doing that kind of work. First of all, it guarantees eventual task execution. No matter what happens, be it timeouts, problems, scheduled maintenance, unscheduled maintenance, whatever happens, task queue guarantees that your task will be executed. You do not need any kind of external drivers. You can fire your task and go home, close your computer lid, and sleep well. Task queue repeats task execution if something bad has happened. If you had some kind of unavailability, or you had some transient error, or your URL fetch did not work through, you just return a 500 result code, and task queue will retry, and it will back off if you have too many errors. And also, most people do not think about that, but task queue can limit execution rate so that you have a predictable resources consuming predictable amount of resources. Because it's really easy with task queue to blow up through your whole budget in 1 hour. You just execute a couple million of tasks, and you spend all your money for the day. So the whole App Engine idea is to take something which works for Google and to give it to external developers. And it's true that everything in App Engine runs on the same servers, in the same data centers, which our usual day-to-day programs run. We don't have any special data centers for you. We don't have any special infrastructure built. At Google, MapReduce has been used for years and years to do batch processing at our Google scale. And MapReduce as a system was specifically created to help developers work with unreliable distributed systems, storages, failovers, retries, and it's really, really widely adopted. So at Google, there are thousands and thousands of MapReduce jobs running. MapReduce is really, really simple thing. You just define only two functions. You define the map functions, which takes your data chunk, maybe entity, and it produces a list of pairs of key values. Then there is a hidden magic step, which is called shuffle, which groups all values with the same keys together. And then there is a reduce function, which is also supplied by developer, which takes key and also shaded values. And it's amazing how broad tasks can be completed with a task queue. A special interest are schema migration task, which is usually an empty reduce. So you've got only map function, which reliably scans through your old data set. And in your update function, in your map functions, you just update your data store and migrate or compute something. And another one, really special case, is report generation, when as a step of reduce function, you just generate new report entities, which have some report data for consuming with other pages or other apps or other tools. We would really like to give you the same MapReduce which we are using at Google internally. We would really like for you to use the same implementation, same systems, but unfortunately there were and there are some unique challenges which we have at App Engine. First of all, we've got additional scaling dimensions, which is not common for Google. We've got lots of applications which were written by you guys. We've got thousands and thousands of apps, and we expect that many of them will run MapReduce at the same time. And this scaling dimension was not anticipated by our MapReduce engineering team, so MapReduce cannot do that. And another problem is that we want to isolate all apps so that if some apps is behaving badly or consuming lots of resources, then other apps should not be hurt. So no one wants to have his MapReduce running slow because someone else is running his MapReduce. So we want to do lots and lots of isolation stuff. We also want to do rate limiting, which is a surprising requirement, because at Google we want our MapReduces to continue as fast as possible. But we realize that is not what you guys want, because we can consume $1,000 of resources per hour, and not everyone might be happy with the rate of resource spending. So you probably want to limit your resource consumption. And some apps even want a very, very slow execution. If you're a free app, you've got a certain amount of quota daily. You do not want to consume it in 5 minutes and kill your app or whatever. And the last but not least, we want a protection from malicious app engine users. There are some people who try to exploit our infrastructure to gain some advantage or just take a look how Google operates, and we have to be protected from that people. We have to protect your data from that kind of people. So that means that we could not take the existing MapReduce and give it to you. So we have started to build the whole system from scratch using probably some building blocks which we have already available. And we realized that we already have a really, really nice subsystem in App Engine which solves most of the problems we're having, and that system is called task queue. So we decided to build our MapReduce framework on top of task queue, probably adding some necessary services while we go. So today, I'm pleased to announce that we have successfully completed part 1 of MapReduce story. We have implemented map, which is not all MapReduce, but we decided that it's already useful enough for you guys to work on. And it's reliable, fast, and efficient way to iterate over your data store or blob files or whatever other data source is possible. You can start playing with it today, and while we're extremely busy of giving you the full MapReduce, you can already start using it, take a look at our APIs, and write your code. First of all, the code in Mapper library is completely user space. You just pull those sources into your project, and it works. It's fully open source, so you can tweak it, modify it, change to your needs, see how it works. You can create patches, send those back to us, and build them, introduce them to our code base. Today we are launching Python version. Unfortunately, Java version was not in this state we're happy to open right now, but it will come really, really, really soon. And we tried to make all the APIs very familiar to Hadoop and Dumbo users so that it's close to being source compatible, but what in reality it means if you know what Hadoop or Dumbo is, you can start really fast. So speaking about features, we have automatic sharding. So if you have a huge data set, we can process in parallel lots and lots of shards. So we'll split your data sets into manageable chunks and work through them. You can rate limit for slow execution. We have status pages so that you can see how well is your MapReduce doing, what is it doing, what's the progress. We have counter support, which means that you can count certain events in your data set and use it as a reporting tool. We can have parameterized mappers so that you can create a mapper which can be used with different parameters to tweak it or to tune what to work on, so that engineers create MapReduce and an administrator run it later, or you can create reusable MapReduces. We have batch and data store operations so that it works much, much faster than the code you would write by hand. And you can also iterate not over the data store only, but over the blob. So now we'll try to give you a small demo. Let's hope that Wi-Fi gods are in good mood today. So we created a small app which basically scans the source code of the zip file which you have uploaded and looks for certain regular expressions. So for this demo, we have uploaded the source code of Linux kernel tree, which is approximately 100 megabytes of a zip file, which is close to 1 gigabyte of raw source code. So there is a MapReduce system overview page, which shows you all the MapReduce which we have run recently. Here they are. Do you need to zoom in? Yeah. You can also start a new job. So let's try it. These are just parameters. This is not like really user-friendly. Just just a bare UI which we've got. So we specified the file ID. We're going to look for crap in Linux. And the regular expression will be crap, and we'll do it in 20 shards. So we're going to hit run. It takes some time to analyze the data set and then queue all the tasks. So it says that, hey, the job was successfully started. Here is the job which is being run. We can check the task queue of our app. It says that we've got 21 tasks, 59 we have already run in this minute. We will continue running. Meanwhile, we can check the status page of individual MapReduce, which will show us how our MapReduce is doing. So we can see this is like a progress of each separate shard, how many files has it processed. We can see that by now it has done 4,000 mapper calls, which is approximately 140 calls per second, which means we're processing 140 files per second. And you can see, if you're interested in the status of individual shards, how well are they doing, like how long does it take. You can refresh and check. But meanwhile, while it gathers, it writes all the data to the data store so that we can already take a look at results. So this is all mentioning of crap in the Linux source code. Depending on the luck, like yesterday, same MapReduce is completed in 2 minutes. Today, it took like 8 minutes, which is 2 minutes, I think, is quite good for 1 gig of source files to do regex on every line of every source file in Linux tree. So we will probably check later in the demo, in the presentation. So we see that there are only 9 shards left. So like 11 shards have already completed in 1 minute, 40 seconds, and everything will complete eventually. So meanwhile, let's see how the API looks like. Oops, we lost our slides position. So it is really, we tried to make it really, really easy for you to start using the library. It takes exactly 2 steps. First step, you check out library from Subversion directly into your source code using SVN checkout or SVN export. And then you just add these 3 lines to the app.yaml. You specify URL. Sorry, this is an error. Instead of script location, it should say MapReduce, and you say that this is admin protected pages, which is probably a good idea. You do not want your users to start MapReduces. And it is really, really easy to define a new mapper to do some work. You define a simple function which takes only 1 argument. You do something with that argument, and you create a MapReduce YAML file in your app, and you specify your mapper, that how is it called. It's operating over data store, and it has the handler and those kind of stuff. And then you can open your app and /MapReduce, and all the MapReduces will be listed there. You can start those from UI. In Java, it's gonna look a little bit more messy. Like, you have to define class, extend up engine mapper, key entity. To be honest, I have left 2 additional parameters, generic parameters here, because they come in from Hadoop. This is not our interface, but this is exactly how Hadoop interface looks like. So you can write it the same way. But it's quite simple anyway. So this is first example how you do your data store operations. You specify a function. You just accept, for example, user. You do something with user. You tweak its properties. You change its stages. You calculate something. And then you yield the operations you want to be performed. You yield operation dbput from user, and we'll collect all those operations together from multiple runs, and we'll do them in batches. We make sure that you do not cross the 1 megabyte of request limit and all that kind of stuff. And with put, you can also use delete, or have some other fancy operations. Counters can be really, counters is just something which keep tracks of simple integer value, and you can use it to build some kind of repo generation. For example, if you want to know how is your audience age distributed, you just introduce lots of counters depending on user age, and you increment the specific counter. And on the status page, you would be able to see all the counter values. And you can have probably on the order of magnitude of 1,000 counters. So you can do pretty nice reports using counters alone without any difficulties. And this is the example how you might generate a more complex report. For example, if you want to see how many goods each customer has ordered from you, you define a mapper over your customers. Then inside the code, you look for all orders by this customer. You sum the total. You create the report line, and you yield an operation to put the report line back. So then you'll be able to start this MapReduce. You can even create a cron job, which will run this mapper like every day, and you will have a fresh report every morning with all the information you need. Some implementation details is that we're using task queue chaining to do all this stuff. And there are two types of flows inside. The first one is a controller flow. We have a separate task which oversees all the execution, all the statuses, log messages, whatever, and gathers information together, helps to display a status page. And we have workflow, which you have really a lot. So we've been running our examples with 20. You can have 40, 100. That depends on the data rate you want to achieve. And all this tasks use data store for storage and communication, and we optimized it really hard to do like just one read, one write during the whole operation. So the overhead there is some overhead of using this, but it's pretty low. And we handle most of the complexities. We're making sure that there is no like unnecessary fanouts. There is no infinite forking, but there is only one thing which we would like you to keep thinking about when you write MapReduce, is idempotency. And the idempotency is a really important concept for all batch operation. So idempotency in mathematics, it means that if you apply function twice, then you have the same results, which in our case means that your batch handler should be ready to process the same entity twice. Because errors do happen, and the way we recover from errors, we rerun your code in the same entity. And sometimes you might be unlucky, and it will be rerun twice. And this is the most important property you should think about. When you write the batch operation, you should always think, is it idempotent? Do I care about that stuff? And let's take a look at some examples of practical idempotent operation. So this is naive data migration, which is not idempotent, because it creates a new property, it computes it, and it puts entity back. And if it's run twice, it might, on the same entity, it might give not the same results which you would like to have. So, oops, it's the same code. I'm sorry for that. So basically, the way to make it idempotent is that you have to check that you have performed that migration in your entity already. If you have performed it, there is no need to do any additional work. If you haven't performed it, perform migration, flip the flag, or whatever you have, and put it back. For example, if you decide to migrate from a 0-based value to a 1-based value, you should introduce a Boolean flag of whether you performed migration or not. Or otherwise, you can increment that value twice. It's a rare event, but we do not want to take chances. Another example is doing reports. So reporting by customer, you generate report lines, and you put report lines back into database. Again, as I said, this is not good, because you might process the same customer twice. There is a way out of this. In your final UI, you can check if you've got the same report line for twice, double report line for the customer, and you can decide that, hey, I'm going to drop one. But it's really, really easy to create another important version. You have to specify unique key names for report lines. Just, for example, build it from report ID and customer ID, and data store will make sure that you do not have double report lines for the same operation. And what will actually happen here if you're going to process your customer twice is that you will try to put it once again, it fail, and the next time, there's the first statement of this report generation function, you should probably check that you already have report line in the database, and if you have it, no need to generate another one. And the last one, which we had previously, which is obviously not idempotent function, which yields counter increments. If you process the user twice, you'll increment the counter twice. And frankly speaking, there is no easy way to achieve idempotency in this case. But one might argue that you do not need idempotency in this case. And that's why. And mostly will run your reports over live data. Data which is being constantly changes. And by the whole nature, reports of these kinds, like distributions of users, are approximation. So if error rate is not really high, you might have 1 or 2 users off. Like you will figure out that there are not 1,500,000 users of age 30, but 1,500,000 plus 1 user age 30. So nobody cares. And this kind of reports are really problematic, but we do not know right now what's the really good idempotent way to generate those. So in summary, we've got the mapper library, which is available today. You can already download it, play with it. It's reliable, fast, and efficient. It can iterate over a data store, or as I have shown you, it can iterate over blob files. We have 2 ways to iterate over blob files already. The first one is to iterate over a zip file, and the other one is to iterate over lines in a text file. So you can easily build whatever import your data. We've got Python now and Java really, really soon. All the code is fully open source. And before we go to questions, let's check how our MapReduce is going on. So we refresh the page, and this is the top job which we have run, and it took 2 minutes, 49 seconds to iterate over 1 gigabyte of text data, which is probably quite good. I would say that this is comparable performance with a workstation, with the local data, and all the data is in the cloud, obviously, and if you care, there is a list of all the crap in Linux kernel. So now we're going back to questions. So if you haven't seen, this is the URL, which is bit.ly ds6t9f. Any live questions while it loads?
This is about idempotency.
Yes.
Typically, when you have idempotency, you know that all of this data needs to be committed.
Yes.
Right. But let's say if there is a business transaction where there is a counter transaction involved, like for example, you book a hotel, and then a car, and then a flight, and then when flight gets cancelled,
yes,
then you go and redo all of them. If you have already committed, and if you're trying to do an idempotent action in that case, you need a counter transaction where idempotency will not work.
Yes, so basically what you need to do is to keep track of which transactions you have applied recently, for example. Just keep a tombstones and just to make sure that you haven't done that.
Is there a project which has something like change summary or snapshot of a particular transaction that you're planning to build?
You see, this idempotency is not connected only to live-changing data. Yes, you could somehow like freeze your data set, redirect all live traffic to somewhere to like maintenance page and try to MapReduce. But again, the mapper stuff is running on a distributed system which has failures, and it might execute itself twice on the same entity. So it's the way our Google MapReduce works. It's the way our MapReduce works. It's the way Hadoop works. It's just the way distributed systems work. Sometimes you might do this. You have to be expected to do the same work twice. You should use tombstones, keeping track of what has been done, of what not.
This is pretty sweet, man. Nice job. I was just wondering, it seems like it'd be pretty useful to do some bulk loading of like big data files with MapReduce, or is that not really the intention? Like, would that not be a good use case for it? So instead of bulk loading with the client, just like upload a blob and process that and create entities, would that be like more like efficient to do it?
Yeah, so the question is, should you use mapper stuff for bulk loading and bulk downloading data? Yes, you probably should, and we do plan to rewrite our bulk load and bulk download to use this stuff. It just so happened that these things were developing in parallel, and we did not want to introduce dependencies, but now they're ready, we can just rewrite it. And in the future, you will be able to do much more from mapper, not just read something, you will be able to write somewhere and generate blobs and all this kind of stuff. So is it possible to use threads in the map computations? It is not possible to use threads in App Engine right now at all, which means that it's not possible to use threads in map computation. Do you have an example of using App Engine MapReduce in combination with the prediction API? No, I do not. Frankly, I did not see prediction API working at all yet. So, but it should be really, really easy to build such thing. So like the reader for iterating over zip files was built by one of our developer relations guy in like 30 minutes. So I would argue that it's going to be probably easy to adopt that kind of API. Please, could you compare the pros, cons of using Engine for MapReduce via batch processing versus using the new Google Storage and BigQuery APIs? The BigQuery API is specifically tailored for analyzing huge data sets. While with Mapper, you can do much more than that. First of all, you can work on immutable data, because BigQuery requires your data to be frozen. You upload it to a big store, and it will live there forever without any changes. You can analyze that. It has some utility value, but it's not going to work over your life changes in the data store. And the other thing which is really important, you can actually change data store from the Mapper library, which is what is being used a lot. Like Brad was migrating lots of data in PubSub Hub and achieving high throughput with this library. Can you discuss an example of batch processing with Google Storage? Yes, it is possible to build a reader which will read data, because Google Storage has a block reading. You can specify offset and read from that offset. It's very similar to our blob store API. So it is possible, and we'll probably build it soon, a reader which will iterate over data in Google Storage. We do not care where the data comes from. As soon as you can fetch data, as soon as you can efficiently split it, you can iterate over like S3 data set if you need to. And how can App Engine overcome bandwidth limitation if batch processing is to be done in the cloud? Upload your data to the cloud. And you won't have bandwidth problems. So any more questions from the audience?
So I have an application in which I'd like to send, say, for example, 5,000 emails pretty rapidly. And I normally would have just used the task queue. But it seems like it may be really easy to do using the mapper.
Yes, you can do whatever you want from mapper code. You can write any kind of code inside mapper. Any legal App Engine code is legal to use inside the mapper handler functions. If you want to send XMPP messages, fine, just send those. We just build those yielding operations because we have provided some special properties, like we batch them together.
So you took away a lot of the complexity of writing my own task queues.
Yes, that's kind of the idea of having this thing. So you can send emails, notifications, whatever. And rate limiting is especially important for sending emails, because you cannot send more than a certain amount of emails per fixed amount of time. Because you're not spammer. Yeah, probably.
Can I ask,
Yeah.
the bulk downloader,
Yeah.
is it true that by default, I mean, I have to write a class to download. I would think that if I want to download, shouldn't it just download everything in that entity? You know, like, why do I have to write a class to do in the exporter class? In the future one, will it do everything by default?
I honestly cannot comment about bulk downloader because I'm not really on top of the recent developments. So you should probably come to our office hours, and there might be people who know about that.
And you don't know about the future either, because you said that it's going to be part of Mapper. Okay.
Yeah, like Brett.
How does it compare to Hadoop?
We are trying to give open source friendly APIs so that if you're familiar with Hadoop, then you can run your code in App Engine with little or maybe even no modifications. So in future, when we'll have a full MapReduce stack with Reduce part, which we like to give you sooner than later, you'll be able to run almost Hadoop code on this stuff, but there are no connections with Hadoop implementations per se.
Is it going to be faster?
Well, Hadoop does not work on Google infrastructure.
Yeah, but
so we cannot use it.
But doing the same kind of analysis on your MapReduce and on Hadoop, which one will be faster?
Sorry, I did not get.
If you run the same, let's say you want to analyze, you run your crap search on Google, and you run the same on Hadoop.
Yeah, so if you engineer it carefully enough, then the odds are high that you will be able to run the same thing without modifications in the Hadoop cluster or in the App Engine cluster.
But do you know which one will be faster to get?
No idea. Right now, though we are quite pleased with performance, the performance was not our goal right now. So our goal was to give you as flexible, as easy tool as possible. Okay. And if we figure out that there are customers who care about certain terabytes, we'll see what we're going to do next.
Thanks.
Hi. Yeah, so once you have the APIs in place, map and reduce, and they're kind of proven, would you consider switching out the implementation to allow for more parallel execution instead of using the chaining technique internally? But if that's abstracted away.
Yes, we do consider that direction, but right now we realize that probably most of our customers are small to medium apps. By medium, I mean medium data sets by Google standards. So as soon as there is a customer who has hundreds of terabytes of data, we might give him another solution.
So if I ask the right people, perhaps there's a preview, something coming up.
Well, we have nothing to announce at this point.
Okay, all right.
So thank you all for coming. I hope you'll try it and you'll find it useful for your app.